In this video, we will examine the functions and features of the Fujikura 35S that facilitate efficient, low-loss fusion splicing. Additionally, we share valuable tips and tricks to enhance your splicing process. If you haven't viewed the previous videos in our Splicing 101 series, I recommend going back to watch them. This will ensure you have solid understanding of the fundamentals, enabling you to start off on the right foot. For a more comprehensive introduction to optical fiber, check out AFL's videos, Introduction to Fiber Optic Technology. This video explains the properties of optical fiber, different types of optical fiber, and commonly used terminologies in the fiber optic world. As a successor to the widely adopted 31S Plus, the Fujikura 35S maintains the same high standards of performance, durability, and reliability while enhancing various aspects of the splicing experience. A significant innovation is the introduction of the industry-leading dual fiber prep system, which contributes to an impressive 30% reduction in overall splicing time, nearly halving the preparation time. Key technology driving this advancement include the SS05 dual fiber stripper, the addition of the AD16 adapter plate to the CT16 cleaver, and the redesigned sheath clamps, facilitating easy one-handed fiber loading and simultaneous placement of both fibers into the splicer. When you open the 35S case, you'll likely find a kit similar to mine, which features the splicer, the CT16 cleaver, the SS05 hand stripping tool. Additional accessories such as the splicer's charging cord, a USB cable, a set plate for use with fiber holders, splice-on connectors such as the AFL Fusion Connect are also included. The 35S comes with newly redesigned sheath clamps pre-installed, but it also provides SP04 set plates, 250 micron, and 900 micron fiber holders as alternatives if you choose to splice using fiber holders. The splicer can be set up to match a variety of work styles and workflows. Devoting time to the setup process will ensure that splicing remains the simple and quick procedure it should be. Following proper setup steps allows you to customize the splicer to align your preferred workflow. Setup begins when deciding whether to splice using sheath clamps or fiber holders. The newly redesigned sheath clamps are designed to facilitate a dual fiber prep method, allowing you to load both fibers into the splicer simultaneously. By holding your fiber in place and gently pressing down on the rear of the sheath clamp, you can easily position the fiber, then close the clamp lid to secure the fiber in place. When using this method, you also have the option to synchronize the sheath clamps with the wind protector's opening or closing motion. Flip the switch on either side of the wind protector to engage and disengage each clamp. When engaged, the clamp opens whenever the lid is open and closes whenever the lid is closed. With the sheath clamps linked to the wind protector, it's crucial to note the inclusion of the secondary fiber retention clamps, a feature previously exclusive to the universal sheath clamps of the 90S Plus. During use, the secondary fiber retention clamps remains closed when the sheath clamp is open. Lift it up and out of the way once the splice is lifted. This keeps your fibers under control, so when you're finished with the splice, you don't need to worry about damaging your unprotected splice. If you're working with 900 micron tight buffer coated fiber, strip off the outer coating in short 1/4-inch pieces. Afterwards, use the smallest hole of the strippers to remove any remaining 250 micron subcoating. If you're using 900 micron loose tube or furrication tubing, you need to swap out the standard sheath clamps with the loose tube compatible sheath clamps, clamp S35B loose buffered sheath clamp. These clamps have a protrusion that securely holds the fiber within the furrication tube, preventing sliding as the splicer handles it. Using the correct sheath clamp with loose tube fiber helps avoid motor overrun errors. Alternatively, the fiber holders, also referred to as chucks or sleds, offer a user-friendly option for handling fibers, allowing for a more substantial object to grip. To splice using this method, you need to transition from the factory setup by 1. Removing the sheath clamps from the splicer, 2. Installing set plates in place of the sheath clamp, and 3. Removing the adapter plate from the cleaver. The AD16 adapter plate has the same size and shape of a fiber holder, so removing it allows you to load a fiber holder directly into the cleaver. Each fiber holder has a magnetic lid to hold the fiber in place, along with 2 guide holes to line the fiber holder on the guide pins of the installed set plates. Once your setup is complete, load the fibers into the fiber holder with about 30 millimeters or 1 1/4 inch of fiber extending from the end. Strip the coating off the fiber, clean, cleave, and position the fiber holder onto the guide pins to secure it in place. Splicing with fiber holders enhances ease of use and minimizes handling errors during the splice. Once loaded into the fiber holder, the fiber doesn't need to be removed until the splice is finished. This ensures consistent cleave length each time, and the fiber ends consistently lands in the same position in the splicer. The next step in the setup involves selecting the operational settings that match your workflow. Keep in mind that these settings can be adjusted at any time, so feel free to experiment with different options to determine what best works for you. Power on your splicer and navigate to Home, then Splice Settings, then Fundamental Settings. Within the Fundamental Settings menu, you can toggle the pause setting and then Auto Start Trigger settings. Turn pause on to have your splicer pause after completing fiber alignment. This allows you to inspect the preparation quality of the fibers before they are spliced together. Turn the Auto Start Trigger setting to either on or off based on your preference or the level of automation you want your splicing process. The last step of the setup process involves conducting arc calibration. Select the shortcut to access arc calibration function. Prepare 2 standard single mode fibers as if you were going to splice, loading it into the splicer, and press the play icon to start the process. This only takes a few seconds and is not only integral to the initial setup, but should also be performed at the start of each day to keep your splicer running at peak performance. The 35S comes equipped with active fusion control, optimizing your splice outcomes. With active fusion control activated, any cleave angle between 3 and 5 degrees triggers automatic adjustment to the arc parameters. This feature minimizes splice loss effects associated with large cleave angles. Once your machine is set up, choose the splice mode that corresponds with fiber type you'll be working with and select the heater mode that corresponds with the shrink sleeves you have. In this case, I'm using 2 standard single mode fibers, so I'll opt for SM Auto as my splice mode. Choosing the right splice mode is a crucial factor to successful splicing. Be sure to identify the fiber type you're using and choose the splice mode that corresponds with the fiber at hand. For example, if you're splicing single mode fiber to single mode fiber, you'll likely start with SM Auto, SM Fast, or SM to SM. Similarly, when splicing multi-mode fiber to itself, you'll likely begin choices such as multi-mode auto, multi-mode fast, or MM to MM. Any splice mode with the word auto after it will monitor arc power with each splice, making minor adjustments from one splice to the next. This helps maintain accuracy in arc calibration as environmental conditions change throughout the day. It's important to note that this isn't a substitute for daily arc calibrations. Factors like temperature, barometric pressure, and humidity impact the required arc power for precise fiber melting. Since conditions can vary daily, start the day with quick arc calibration and then use a splice mode ending in auto to keep the initial calibration's accuracy as conditions evolve throughout the day. Splice modes with the fast suffix will assume the correct fiber type is loaded. Adopt the most recently calibrated arc power value, perform the splice in as little time as possible. Splice modes without a suffix following the listed fiber type is categorized as special modes. These modes have an extended parameter list that you can customize for your splice recipe. Choose one of these modes when working with a special fiber type or if you need to adjust certain parameters. Choosing a heater mode is fairly straightforward. In most cases, single fibers are protected with 60mm, 40mm, or Fuse Connect protection sleeves. However, heating profiles are also available for various other types of protection sleeves. After selecting your splice mode and heater mode, prepare the fibers for splicing following the acronym SSCCL, which stands for sleeve, strip, clean, cleave, and load. Sleeve. Slip a clean protection sleeve over one of the fibers you're about to splice. Strip. Use hand strippers or thermal strippers to remove the protective coating from the fiber. If applicable, load the fiber into the appropriate fiber holder before stripping. Clean. Wipe the exposed glass with a fresh, lint-free cloth moistened with either FCC2 fluid or 99% or greater isopropyl alcohol. Cleave. Load the clean fiber into the cleaver, fully raised, and gently lower the cleaving arm to cleave the fiber. Remove the fiber from the cleaver before returning the cleaver arm to the ready position. Load. Immediately after cleaving, load the fiber directly into the splicer without placing it on any other surfaces. Placing the fiber down anywhere increases the risk of getting dust or dirt on the cleaved end of the fiber and the V-grooves of the splicer. Never clean the fiber after cleaving. It might seem counterintuitive, but this will actually deposit more contamination on the cleaved end of the fiber. Developing good, consistent fiber prep habits will not only be appreciated by your equipment, but will also be reflected in the quality of your splices. Once the fibers are loaded in the splicer, visually confirm the position of the fiber ends. Ideally, they should both land about halfway between the inside edge of the V-grooves and the center line of the electrodes. Close the wind protector. At this stage, depending on the operational settings, the splicer may start automatically, or you may need to press the set or play. Unless you've activated any of the pause options, the splicer will seamlessly progress through the entire process. You'll see the fibers come together, be inspected by the splicer, and be spliced together. Gently remove the spliced fibers from the splicer and use the positioning feature on the top of the heater oven to place the shrink sleeve over the splice. If you're using sheath clamps, there's an additional positioning feature. Grab the fiber opposite the protection sleeve at the edge of the sheath clamp. Grab the protection sleeve side and lift the whole splice out of the machine. Then tilt the fiber to the center of the sleeve over the splice point, using your fingers as a positioning stop. After aligning the sleeve, hold tension on the fiber and lower it into the heater oven. Fiber splices have excellent tensile strength, so there's no need to worry about breaking the splice. Hold the splice in the position until the heater element secures the splice protector. Releasing it too soon may cause the sleeve to fall below the heating element and not shrink correctly. When the heating cycle is finished, lift the protection sleeve from the oven and allow it to cool off. Be careful, as it will be hot, and wait a minute or so before touching it. The splicing and heating function of the machine operate independently of each other, so you'll be able to begin the next splice as soon as the heating cycle starts. Now that the splice is finished, take some time to practice with a few more splices, experimenting with different operational settings. Getting to know your equipment is key to future splicing success. The better you know your machine, the easier it will be to recognize issues and keep yourself up and running. The 35S is a precision calibrated machine functioning within exceptionally narrow tolerances. By spending time reading the instruction manual, following recommended procedures, and maintaining regular cleaning and upkeep, your equipment will thank you and the quality of your splices will be clear.